Now let's find out more about scale drawing. An enlargement is an example of a scale drawing. A scale drawing shows an object with its measurements in proportion to the actual measurements of the object. A scale is a ratio that compares the measurements used in a scale drawing with the actual measurements. The scale used to enlarge the photograph was 1 inch to 4 inches. Scales can be given in the same units or in different units. In this case, it's the same unit. 1 inch to 4 inch. 1 inch to 4 inch. You can put that in the units as well. That means it's 4 times its size. A scale factor is a constant of proportionality. When the units in the scale are the same, it tells you how many times larger or smaller the measurement of the actual objects are compared to the measurements in the scale drawing. For scale 1 inch to 4 inches, or 1 to 4, the scale factor is 4, just like we talked about before. Scale drawings are typically used when objects are either too small, or too large to be drawn at their actual sizes. Maps are scale drawings. Think about that. Okay, architects use scale drawings when they design buildings. Floor plans and maps are drawn smaller than actual size. Drawing of cells in biology are drawn larger than actual size. I want you to really think about that. Okay, and I know that every map that you have seen should have a ratio. Scale factor right here. This one for this drawing, it says 1 inch is 10 feet. The floor plan shown is an example of a scale drawing right here. The scale 1 inch to 10 feet can also be written as 1 inch equals 10 feet. So for every inch, that means that 1 inch on the floor plan represents an actual distance of 10 feet. So this floor plan, 1 inch, let's say, in actual distance, it will be 10 feet. Think about that. Okay? Let's reflect on what we just learned. What is the scale of a drawing that shows a length of 2 inches when the actual length is 36 inches? I want you to pause this video and then unpause, and you'll get the answer. Just you can check your answer. The scale is the ratio of 2 inches to 36 inches. And if that's what you got, you obviously got that correct. 2 inches to 36 inches, or 1 inch to 18 inches simplified. Best way of doing that is actually writing it out. 2 inches to 36 inches, and simplified will be 1 inch to 18 inches. There you go. Now let's solve this problem. Read the problem below, then explore how to use a scale drawing to find the actual measurements using proportional reasoning. Okay? Below is a scale drawing of a soccer field, as you can see. A length of 1 centimeter in the drawing corresponds to 15 yards in the actual field. Obviously, we can't draw the actual field, so I want you to visualize that for a sec. So 1 centimeter corresponds to 15 yards. 1 centimeter, 15 yards. 2 centimeters, 34, right? You can see the length here is 8 centimeters, and the width is 5 centimeters for this drawing. Okay. The question says, find the dimensions in the area of the actual field. Here's some clues. Measure it. You can look at the labels to find the measurements of the drawing. We just did that. The width of the field is 5 centimeters right here. Okay. And then the length is 8 centimeters right there. Here's some more clues. There's 2 model it. Let's look at the first one. You can use the scale to make a table of equivalent ratios. The scale again is 1 centimeter to 15 yards. So 1 centimeter to 15 yards. And they label it. And that's very, very important. Distance on the scale drawing, centimeters. Distance on the actual field, yards. So 1 centimeter is 15 yards. That was given. 2 centimeters, 30 yards. 3 centimeters, 45 yards. 4, what would it be? 5, 6, 7, and 8. Okay? Or you can use the scale to write equations for the ratio in a proportional relationship. Remember, equation has an equal sign, and there it is, and they're writing out proportional relationship. Notice they took the scale, which is 1 centimeters to 15 yards, and they wrote it as a fraction form right here. Okay? And now, they're saying if the width is 5 centimeters, what would the actual distance be? Notice that the centimeters are on the numerator. In this case, they correspond. They have to correspond. That's important. Centimeters, centimeters. Yards, yards. Okay, and then you should know how to solve proportions. We'll get back to that. And then they did the same thing for the length. So this is the width. This is finding the width, and this will be finding the length. Now let's look at some questions that will help you solve the problem. It says to connect it. Now you will use the models from the previous page to solve the problem. Let's look at question 2. Look at the first model. Complete the table and explain how you figured out the missing lengths. Question 3. Use your table to find the actual length and width of the field. Question 4. Look at the second model. Use the equations to find the actual length and width of the field. And I'm hoping that the answers to question 3 and 4 will equal. Question 5. Calculate the area of the actual field. So now they're asking you, what is the area of the actual field? Okay. And then question 6. Explain how you can find an actual distance when you know a distance on a scale drawing and you know a scale. I would pause this video. I'd solve all of these questions, these 5 questions, and then unpause it, and we will go over them. Let's look at question 2. Look at the first model and complete the table. So before we're going to explain how you figured out the missing length, let's look at the completed table. So hopefully for 4 you got 60. For 5 you got 75. For 6 you got 90. For 7 you got 105. And for 8 you got 120. If you did not get that, here's the answers. And try them out. All these are proportional. Okay? For every 1 centimeter, 15 yards. So rate actually goes up by 15 for this table. Always goes up by 15. Okay? Looking back at the question, how you figured out the missing length? Well, one possible answer is the length of the actual field in yard was always 15 times the length of the scale drawing in centimeters. So it goes up by 15, 15, 15, etc. Okay? Use your table to find the actual length and width of the field. What they did with this table, if you look, they made sure that 1, 5, and 8 are all red. This was the given info. This is what they were looking for. So obviously the answer is 75 yards. And this is what they're also looking for, which is 120 yards. Okay, so the drawing width is 5 centimeters. So the actual width is 75 yards because it's 5 times 15, 75. The drawing length is 8 centimeters. So the actual length is 120 yards. 8 times 15 is 120. Now, for question 4, with the second model right here, okay, with the proportions. Notice how they set this up. This information was given 1 centimeter, and I always like to write the unit so we know they correspond. 1 centimeter, 15 yards. 5 centimeters is how many yards, right? You can see centimeters correspond with centimeters. Okay. So now they did that here for you, and all you have to do is find the missing length here. Okay. If you don't remember how to solve proportions, we can help you. It's cross multiply, or in this case, you would do 1 times 5 is 5. 15 times 5 will give you 75. And then they wrote it in complete sentence as you should. A width of 5 centimeters on the drawing equals 75 yards on the actual field. And again, they did the same thing here. 1 times 8, 15 times 8, 120. A length of 8 centimeters on the drawing equals 120 yards on the actual field. So you can see that both of these answers are the same. Okay, they just use proportions for number 4. And the table for number 3, excuse me. Number 5, now it says to calculate the area of the actual field. Where if it's 75 by 120, think about how you find an area of a rectangle. Area of a rectangle, I was about to draw it, which is fine. Length times width, or base times height, right? So the length is 120, and the width is 75. And when you multiply them, hopefully you guys got 9,000 square yards. Remember, the units are important. We're talking about the actual field, which is measured in yards. And then question 6, explain how you can find an actual distance when you know a distance on a scale drawing and you know a scale. Well, one possible answer is use the scale to write an equation that shows a proportional relationship, there's the equation, and solve for the missing value. Now I'm going to ask you to solve these 2 questions on your own for great practice. You're going to try this on your own. You're going to pause the video. I will read these questions to you. And then, pause the video, solve it, and then you'll have your answers. Question 7. On a scale drawing, a building is 5.5 inches tall. It's always good to draw this. Alright, so I will draw this. If the scale of the drawing is 1 inch to 8 feet, how tall is the building? Question 8. For a school project, Leo is making a model of the Statue of Liberty. He's using a scale of 2 centimeters to 3 meters. The Statue of Liberty is 93 meters tall. So how tall is Leo's model? I want you to think about that carefully. The best thing to do again is to draw it out. Let's see what we got. Well, let's look at the answer for number 7. If you got 44 feet, great job. If you did not, we're going to go through it right now. Remember, if the scale, watch how easy I'm going to try to make this look, or be. It's 1 inch to 8 feet. Okay, watch this. 1 inch to 8 feet. That's how we're reading it. A building is 5.5 inches tall. So if I was to write a proportion, where do you think the inches would be? Numerator or denominator? 1 inch, 8 feet. Clearly on the numerator, because they have to correspond. So now we have, I put the little variable n because that's what we're looking for. 1 inch to 8 feet equals 5.5 inches to how many feet? And now you just cross multiply, right? Or you can, you know what? Well, let's do cross multiply first. 1 times n is 1n. 5.5 times 8 is 44. And then obviously divide by 1, or just, you can leave it as n, right? Because 1n is the same as n. So n equals 44 feet. There it is. Okay, that's one way of doing that. If you created a table, you would do 1 inch to 8 feet. You would obviously label it. I'm just going a little bit quick here. Alright, there's more. 2 inches would be what? 16 feet. 3 inches, etc. Till you get 5 to 5.5. Okay? But I still think the best way of doing it is using proportions, as you can see what we just did. Let's look at number 8. Let me set this up first, and maybe use a different color so you guys can see that as well. For a school project, Leo is making a model of the Statue of Liberty. He's using a scale of 2 centimeters. So let me just do different colors. 2 centimeters. Let me use the fraction bar as black right here. and 3 meters. Okay. Put equal. Okay. Think about what information is given. Okay. The Statue of Liberty is 93 meters tall. So they're giving you the meters. 93 meters tall. So obviously they're asking, how tall is Leo's model? There it is. Right? And now, let's do the math. Again, solving proportions, cross multiply. You learned that in the previous lessons. And now let's do this out. I'll use a different color. 2 times 93 will give me 186. N times 3 will give me 3n. This is an equation. We're going to divide by 3 on both sides of the equation because it says 3 times what equals 186. Excuse me. And 186 divided by 3 should give you, and hopefully you guys got this, 62 centimeters. And that's what we're looking for. 62 centimeters. Hopefully this helped.